Hi, this is Module 2, Lesson 9, Making My Point, the notes. Here we're focusing kind of on some quilt blocks and this patterns they're seeing. So Zach and Stone were working on predicting number of quilt blocks in this pattern. So if we go through and look here, when we have the first one has 1, 2, 3, 4, 5, 6, 7. First one has 7. The second one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And the third one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19. So when we're looking at this, Zach said he got y equals 6n plus 1 because he noticed that they were adding 6 blocks each time. So it's a plus 6 in between. And so the pattern must have started with one block at n equals 0. So if we back up and do a 0, if we have to do a plus 6 to get to 7, then it must have been a 1 under there. So if we have 6 is repeating over and over, plus 6, and we started with a 1, that's how we got that one. Well, Sion says, I got y equals 6n minus 1 plus 7, because I noticed that at n equals 1, there were 7 blocks. At n equals 2, there were 13. So they used that by taking 1 less than the number of n and multiplying by 6. So because she started with the first term rather than the 0 term, we need to do the n minus 1. We started with a 7. We're multiplying by 6 each time. Okay, so what do we think about their strategies on here? Are either of them correct? Why or why not? So basically, they both are correct. So I'm going to go ahead and use this color. Both are correct. And it's really how we just explained it up there. Because Zach used the zero term and said there would be 1 to start with, and we're repeating 6 over and over. And Sion is saying, well, no, I'm using the first term. I'm repeating 6 over and over, and I started with 7. So both of them, if you would simplify this 6n minus 1, it would still get us the 6n plus 1 on there. So if we simplified, they both would be the same. All right, next problem. The next problem Zach and Sion worked on was to write the equation of the lines shown in the graph below. So when they were finished, here's the conversation they had about how they got their equations. Sion was saying, it's hard for me to tell where the graph crossed the y-axis, so I found 2 points that I could read easily. Sion was in green, -9, 2, so about right there, and -15, 5, so about right there. So I figured out the slope was -½ and made a table and checked it against the graph. So m equals -½ because we're going from -9 to -15, 2 to 5. So let's go ahead and just prove that right here. So -9 minus 15 over 2 minus, or underneath, 2 minus 5. So 2 minus 5 is a -3. -9 minus, a -15, so it's really a plus, would be a 6, so that does equal -1/2. So by finding the slope of these 2 points, we were able to find the slope of 1/2. So when she did, hit that button. So she was surprised to notice the pattern was to start with n, add 9, and multiply by the slope, and then add 2. So she kind of got the equation of f of x equals -1/2 x plus 9 plus 2. Zach says, hey, I think I did something similar, but I used the points. So he used the points 7, -6, so this one, and 9, -7. So 9, -7 was this one right here. So again, if we subtract those, he still gets the slope of 1/2, and he ended up with the equation of f of x equals -1/2 x minus 9 minus 7. They said one must be wrong because yours says you add 9 to the end and mine says you subtract 9. How could they both be right? Well, can they both be right? Are they both right? Let's take a look at this. If we simplify each of these, let's see what we get. So we'll start with Sion. So if I do -1/2 x plus 9 plus 2, I'm going to distribute the -1/2. So -1/2 x plus 1/2 of 9 is 4.5. I'm actually going to do the decimal on here just because it's easier for me in this case. So plus I'm not even going to do a plus. We're going to do minus because it's negative, minus 4.5 plus 2. If I combine those two, I end up with -1/2 x minus 2.5. Okay, so that's what my y equals for this one. Let's see what Zach's ends up being. So his is -1/2 x minus 9 minus 7. Now let's distribute. So again, -1/2 x, so far we're the same, minus negative, that means a plus 4.5, because that's 1/2 of 9, minus 7. Well, if I combine 4.5 minus 7, that actually equals a -2.5. So these guys are equal to each other. So mathematically, we proved that they simplify to a slope of -1/2 and a y-intercept of -2.5, which that's probably about accurate according to that. So if we put it into y equals mx plus b form. Okay, so they are both correct. So Zach said, my equation made me wonder if there was something special about the point 9, -7, since it seemed to appear in my equation. So let's see here. Let's just use this yellow. So I've got 9, -9, and I've got a -7, -7. And he's noticing something interesting. The same thing happens to this equation, that his -9, +9, +2, +2. So what is the pattern that he's noticing? Well, looks like with the x, here it's a +9, here it's a -9. Here it's a -9, and in the equation it's a +9. So the x coordinate is subtracted from x, is subtracted from x, and the y coordinate is added to the end. Is added to the end. So both times we had the x minus whatever our x coordinate was, so x minus 9 in those parentheses, and then we added a -7 or subtracted 7 on that side. Here we had x minus a -9 is actually +9, and then we added 2 at the end. So find another point on the line given above and write an equation that would come from Zach's pattern. So if I go back up there, let's see what other point we can come up with here. Looks to me like we have a point at 1, -3. So I'm going to go back and do 1, -3. So 1, negative 3. See my negative there. That is not showing up. There we go. And so if I follow that pattern, I should have f of x equals, so then my slope is negative half. Then I'm going to do x minus 1, because that's my x right here, minus 1. And then I'm going to add a negative 3 on the end, or subtract 3. So what would the pattern look like with the point A comma B if you knew that the slope of the line was m? Okay, let's come up with the formula for this now. That's what they're asking. What is our generic formula for this equation? So f of x equals, we have our slope in the front because the slope was negative half. Then we're going to have x minus a, our x coordinate, and then we're going to add our y coordinate on the back. Zach challenges you to use the pattern he noticed to write the equation of the line that has a slope of 3, okay, slope of 3, and that contains the points 2, negative 1. So looking back at this guy, how would we do that? I'm going to go ahead and do this one in blue. Let's do purple. Let's do purple on this one. And let's do this. F of x equals, my slope is 3m, parentheses is x minus, my x coordinate is 2, and I'm going to add my y coordinate, which is a negative 1, to the end. There we go, we did it. Show a way to check and see if your equation is correct. Well, if I substitute any point in there, I should be able to, it should match, right? So let's go ahead and substitute in the coordinates of 9, negative 7. So f of x, oh wait, not f of x. So if we're using the coordinate 9, negative 7, I should have negative 7. Does it equal 3 times, oh wait a minute, I can't use that point because that's from a different line. Good thing I caught myself on that. Let's use our original point right here, 2, negative 1. Let's go ahead and use this guy to check. So it should work if we substitute in the 2, negative 1. So negative 1 is my y. Does that equal 3 times 2 minus 2 minus 1? Right? So I substituted, just so you know where I'm going here, the 2 went in for here, and the negative 1 is going in for my, oh, there we go. Negative 1 is going in for my y. So I'm filling this in, my y value. My slope is in there. Oh, shoot. Not that one. I substituted for my x. There we go. That's what's throwing me off. So my x, instead of an x, I'm putting a 2. My x value, instead of a f of x or a y, I'm putting my negative 1. There we go. All right. So from here, back to my colors. Negative 1, does it equal 3 times 0 minus 1? 3 times 0 is 0. 0 minus 1 equals negative 1. So yes, negative 1 does equal negative 1. So we've just proved that it works. All right, keep going. Number 7. Sion challenges you to use use the pattern to write the equation of the line graphed below, and you want to use the point 5, 4. Well, we have a point. The other thing we need to have is a slope, right? We can't do this unless we have a point and a slope. So I need to find a few more points on here. Let's go ahead and use this one. So 5, 4, if I look again to see where it crosses, it looks like it crosses at 2, 3, 4. or just 2 comma 3. So it looks like I have another point at 2 comma 3. So if I use those 2 points, I should be able to find my slope. So I'm going to subtract my y's. 4 minus 3 over 5 minus 2. That is 1 over 3. So my m equals 1/3. All right, so I should be able to write out my equation now. F of x equals, my slope is 1/3, and it is positive, it's going up, parentheses, x minus my x, which is 5, plus my y, which is 4. So there's my equation. So now let's check it. So I should be able to plug in my 2 comma 3, and it should work. So let's try it. So let's do 3. Does it equal 1/3 of 2 minus 5? 2 minus 5 plus 4, right? I want to plug in that point to see if it works. So does 3 equal 1/3 times 2 minus 5 is -3 plus 4. Well, -3 times 1/3 is a -1 plus 4 does equal 3. So yes, 3 equals 3. We just proved it worked. Okay, Zach, I bet you can't use the pattern to write an equation of the line through the points -1, 1, -3, and 3, -5. Well, let's do what we've been doing. Let's go ahead and find our slope first. So -5 minus -3, y's over x's, 3 minus 1, right? -5, 3, -3 over 1. So -5 minus a -3 is +3. So that's -2 over 3 minus 1 is 2. So I have a slope of m equals -1. And I just need to pick one of these points. So I'll go ahead and just pick this first one here. Let's just use this guy for my equation. And so I'm going to put f of x equals -1 is my slope, x minus, I'm going to use here, 1 minus 3. So there's my equation. Now I need to show my work. I'm going to go ahead and use the other point for my check. So -5, does it equal, let's see, -1, parentheses, 3 minus 1 minus 3. Little divider on here. -5, does it equal, so -1, 3 minus 1 is 2, minus 3. So -1 times 2 is -2, minus 3 is -5. Sure enough, -5 equals -5. So I've shown that it works. One more here. This one. Zion says, I wonder if we could use this pattern to graph the lines, thinking of a starting point and using the slope. Try it with the equation f of x equals -2 x plus 1 minus 3. Well, we know our x and our y are in there, and -2 is our slope. So our coordinate must be x minus -1 would give me a +1, and my y coordinate must be -3. So this must be my starting point. I know m equals -2 because it's right here. So now I can use this to graph my line. So -1, I am going to make this a little bigger so I can see this here quick. All right, so my point is -1 comma -3, so right about here. And its slope is -2, so I'm going to go down 2 over 1 which means it's going to go from 3 to 5, 5 to 7, 6, 7, 8, 9 would be about right here. And so now I've got the down 2 over 1, down 2 over 1, and I've got my line. And make that a little smaller. Okay. Nice. So notice we just did the opposite. Instead of looking for points, we were able to use this point and the slope and be able to make our graph from there. Final page. Zach wonders, what is it about this lines that makes this work? How would you answer this? Oh, what do you think? What is important about a line? Well, slopes don't change. And it doesn't matter what point you start with. No matter what point you start with. So that's really the key on this one, because no matter what your slope is, it's going to stay consistent. So no matter where you start, you can go that up 2 over 1 down 3, whatever it is that you need to do from whatever starting point. So that's how this works on here. Could you use this pattern to write the equation of any linear function? Why or why not? Well, if we think about what slope is. So let's look at our slope function. M equals, so we have our y minus y1 over x equals x1, right? So this is our slope function. Let's solve for y. So let's solve this and get the y by itself. So to do that, let's see, let's use green for our motions here. To do this, I first need to multiply by x. Oh, I don't need an equals there. I just need a single line. There we go, minus. So let's multiply by x minus x1. Both sides, x minus x1. That makes these guys cancel. And now we're back to x minus x1 m equals y minus y1. Well, how do I get rid of minus y1? I have to add y1. So we're going to add y1 on this side. These cancel. I'm actually going to flip it around at this point. So y equals m x minus x1. Just switching those around, I can do that with multiplication plus y. And now I'm back into that form when I had that point, x minus a plus b, right? If my coordinate is a comma b, now we have the format we just solved for. So this is really the slope formula rearranged. That's all we've done. So slope formula has been rearranged into a point slope formula. Thanks for joining us, and we'll see you next time.